Welcome to Data Myths Podcast with your hosts, Brian and Malinda Gagnon.
So, a little about us. I'm interested in how tech helps us improve our lives. I have 20 years experience in digital communications. I'm an ex-Googler and now help launch new companies and products.
And I've spent 20 plus years evangelizing tech at some of the world's largest companies. Whether you're a dataphile or a dataphobe, we have something for you on this podcast. So get ready. Let's go.
Hi, good morning, Brian. How are you?
It's a wonderful weekend, and we're recording a podcast again. Woo.
Living the good life. I know. So what's been new with you?
A little bit of travel, but now I've got a little stretch of no travel, so I'm out of the clouds, which is good.
Nice. Well, I actually, funny enough, would like to get us back into the clouds for this chat this morning. And one of the things that I've been thinking a lot about, and especially since our last podcast, when we talked about AWS last week and cloud computing, is to actually dive into that deeper and talk about what that actually is. So I think a lot of people hear the word cloud and it's become very, very common, but I don't think people actually know what the heck it means.
Well, and so I would say when I feel like I need to start doing a stronger job of explaining things to the masses in technology, because there's a lot of stuff that becomes a fancy word and then never really makes it to the general public. When my parents, love you guys, start asking questions like, hey, should we buy or sell gold? We noticed that everybody seems to be doing it. Or should we get the cloud because I got some notification on my phone saying that I should use the cloud? Or, hey, should we get blockchain? It's like, what are you guys talking about?
What about Bitcoin?
What about Bitcoin? So, yeah, I think you should definitely mine Bitcoin.
Yeah, why not? You know, they're retired. could be a fun hobby.
Yeah.
So to think about cloud, right? And it's one of those things that, yes, we hear about it, and clearly people don't even know that actually you are using it. I mean, if you're using Gmail, if you're using a lot of these different types of just everyday services, that you're participating in the cloud. We had a funny chat with a family friend a month ago about AI. I think that was in a recent podcast, and she said, "Do you think it's coming? Do you think AI is something that's going to become real?" And we kind of said, "Well, it's here now. You're using it now, you know." And that's the same type of thing with the cloud. It's here. We're all in it, using it. So, all right, let's talk about what it actually is. So, can you define for me what the cloud is?
First of all, I just want to say robots are very, very sneaky, so you have to watch out for them.
Oh,
same with AI.
That's so scary.
Yeah, no, it is. But yeah, so my definition of the cloud is a pool of shared resources that exist out on the internet somewhere. Now, there are many, many different definitions of what that boils down to, but I think that's a pretty good one.
Yeah, I think so too. So it can be basically shared computing resources for software and data.
Yeah. So it could be shared storage. It could be shared network resources. It could be shared compute. It could be shared database or a web server or whatever.
Cool. And it's accessed via the internet.
Yeah. I think that's a great way to put it.
Cool. All right. So that's fantastic. Now we all know. How does that actually come to life? So there are different ways that we can deploy the cloud. How do we start to break that down so we know how it works?
Well, so let's talk about it a little bit higher level for the moment. And the benefit of the cloud, right, as we speak about it, is that, wow, the cloud has made it really easy to start a business, cheaper than ever, because all of these resources that you traditionally had to have an IT person or really expensive hardware on site, is no longer there, right? So the barrier to entry has never been lower. And that's a great thing. And there's also a number of reasons why that's also a challenging thing, but we'll get into that later. So I think to best serve your question, we need to probably back up a little bit and go before the cloud. So how did stuff work before the cloud existed? So does that work for you if I go back and...
Sure. Take us back.
All right. Wayback Machine again. So if we go all the way back before personal computers even came about, mainframes ruled. And so they built these massive scale compute structures. Some of them were as big as a train car. ENIAC, one of the first mainframes or first computers really, was about the size of a railway car. It took a ton of electricity. It had really expensive components, and it was very, specialized. And so as a result, it took, operators to be able to operate this. And IBM got on that bandwagon as well, started to build all of these mainframes. And by the way, when you go to the airport and you ask to look up your ticket or make some changes, and the person is blankly smiling at you, typing away for 15 minutes, and you're like, there's only 12 letters in my whole first and last name. How could they still be typing? That's why they're typing commands into a mainframe, because most of the airline industry, most of freight, most of all of those major systems, in most cases, still run on a mainframe.
That's really incredible to think about that.
Well, and so mainframe is not a bad, dirty word, but let's talk more about why it sort of fell out of favor in some cases. So the mainframe, big, expensive iron, and in fact, they call it big iron in a lot of cases, expensive to run, expensive to do all these things. Because it was such an expensive resource, they really made sure that it was sized properly and that it was fully utilized as much as possible. And so in a lot of cases, they would have people that just looked at time scheduling, and they had operators, and operators would schedule jobs or applications to run on the mainframe. And boy, those were the days. So if a backup had to run, they had somebody back there moving tapes around until they had robots to do that. That was one actually the first, robotics projects, was changing out backup tapes and bringing tapes back online. I mean, that's kind of fascinating.
So when you say tapes, what do you mean by tapes? What were these tapes like?
Yeah. So if you think of either an 8-track tape, which was before my time, or a cassette tape, it's not too far off of that, but they were digital tapes for making, rather than vocal recordings or video recordings, actually taking data and backing them up on these tapes. So that's some of the Wayback Machine. So now let's move forward. And so that operator person or people that were operating the mainframe, plus how specialized the hardware was, it became really difficult to be flexible. And, policy, procedure, and people, I think many of those operators were people that tried to get into the state police and couldn't, or something like that. And so they had a little bit of that God complex. It's also why in every hacker movie ever, God or Gandalf, for that matter, are the two most used passwords back in the 70s, 80s, and 90s. But that's a whole different story.
The psychology of early computer science would be good.
Yeah, no, look it up. I'm not just making it up. But anyhow, so there kind of became that command and control piece. And so the mainframe is not very flexible, or it wasn't very flexible. So what happened was people started to look at things like, how can we make a mini computer so that we could be flexible and still work on stuff that was still cost effective? So now the early, 80s really come about. IBM PC comes about, the Mac comes about, Altair comes about. And so all of these microcomputers start to come about. And why was that important? Well, that started the birth of flexibility as well as really cheap and economical hardware. And so the client server was born. And because people needed to be able to network, right? And they wanted to be able to take stuff from one PC and move it to another or work in a work group together with people in the office. So networking came about. It got a little easier to do. And now we needed to do something where there was a server that was just running stuff, whether it be maybe answering print jobs and then sending it to the printer or serving up files so that 4 or 5 other computers could get to it, all of those types of tasks. And so the client server was built. And the great part about that, back in the day, people started to just buy them and they put them under their desk, right? And then a bunch of people would connect to them. But over time, they started to grow in popularity because that's where a lot of the development was getting done. That's where a lot of the growth was happening. And it was just so much easier to do that than it was to deal with the mainframe operator. And so when I got to college, that whole battle was just starting to kind of awaken. So there was still a mainframe. All of the emails were off of the mainframe. You couldn't do a ton of stuff. They were very restrictive in how many emails you could have and such. But then a whole nother group on campus built a client server type network where they had mail servers that were much more flexible and they were changing rapidly and getting more features every day. It wasn't, monochromatic text command line stuff. It was actually Windows based. So a lot of those things. And so where did that go, right? So over time, what started to happen is that control piece and that flexibility became a little too much and it just started to grow like wildfire. And so IT professionals then started to say, hey, we got to get back control. So then they started pulling back.
Which they often do.
Yeah. It's a definite control freak
it's their job, but yeah.
Yeah. I could point out some places that didn't have good control. And
right.
Hence your social security numbers and credit card numbers are all over the net somewhere.
So comforting.
Yeah, absolutely. What could they possibly do? But anyhow, so what started to happen is that decentralization started to centralize again. And so now these bigger data centers started to be born. And the reason they did it was economies of scale. Having all the servers in one place, you could have networking that was much more dense and cost effective. You didn't have to spread it out all over the place. And so that was great. But then what happened is it was so easy. It was like, oh, let's just make another file server. Let's just make another web server for another web page. And so every department, every person, every company had hundreds and hundreds of these servers. And some of the challenge with that is that utilization started to drop drastically.
So you're getting more complexity and less utilization.
Exactly.
Those are the two main factors that are starting to tip the scales here?
Exactly. And the other piece to it is now that control started to creep in again. So innovation became harder because there were things like patch cycles where you had to patch the operating system and all of these different problems. And then, businesses have redundancy needs and durability needs of their data. And so all of these challenges started to make the cost of the hardware rise, as well as the cost of operating all of the software rise as well. So now we're into probably the late 90s, into the early 2000s. So the dot bomb just happened. Companies like Red Hat are going against Microsoft big time. Cisco has pumped out a bunch of much lower cost networking at really high densities. And so the data center and co-location, which is taking a company's stuff and putting it in a data center with another company's stuff and sort of segregating it off, that was kind of step one. But then we needed another method. So is that good so far?
Yeah. I think makes a lot of sense. The walkthrough is helpful to see how this all came about and why there was a need for this innovation.
Okay, cool. And so we're getting to the cloud quick. So one of the challenges with this is that all of these servers were different little silos. Hundreds and hundreds of silos. It became really difficult to back them all up. If you ever had a hardware problem, or God forbid, the hardware that you had from last year, you have a failure and now you need to replace it. And oh, wait, they don't make that hardware anymore. Now you have to put it on a different piece of hardware. It became really difficult to have that same stack, so to speak, so that programmers had a very measured, set of hardware and software to work off of. So tons of problems on the DevOps side, development operations. So 1999, maybe even 1998, VMware comes about. And so VMware decides, okay, I'm going to go after the Intel architecture x86 space, and we're going to make it so that you can take a bunch of different physical servers and collapse those down onto one piece of hardware. Sound familiar?
Well, yes.
Yeah. So it's going
Quite
back.
Revolutionary.
Yeah. So that's sort of like going back to the mainframe again. That's taking all of these different jobs, applications, threads, whatever you'd like to call them, and collapsing them down onto one piece of hardware, and then segmenting them so that each one was its own encapsulated virtual machine. So in comes virtualization.
So when you talk about virtualization, did virtualization then come before cloud computing came along?
Absolutely.
Okay.
And virtualization, by the way, actually came out on the mainframe. IBM came out with something called LPARs way back, and it never really caught on. It definitely didn't catch on in the x86 space because they never went for that. So VMware had a big opening and went after the Intel x86 space. And so away we go. And they started going out, talking to companies and saying, hey, you have a problem. You have all of these servers that are just growing out of control. Everybody's got their own server, and the utilization is lower than ever. And so in most cases, even in through the late 2000s, utilization in a server room was below 10%. Wow. Yeah. And so on average, obviously, there are some systems that were higher than that.
So when VMware was first getting started and they're going to companies and offering this service, what were the main benefits that they were talking about?
So that's a great question. So the first main benefit was that you could take a bunch of different operating systems and put them onto the same piece of hardware. So rather than having 10 servers, 10 physical pieces of hardware, you could have one server that was a little bit bigger, and you could take those 10 different versions of Windows or versions of Linux or versions of whatever, and in little containers, so to speak, you could put those on that one piece of hardware. And so as a result, if each of those were only 10% utilized, collapsing that down onto one, little bit bigger piece of hardware, now it's 80 or 90% utilized. So much better utilization. So power, heat, cooling, all of those types of things really got mitigated by that. And so cost savings started to become a really big thing, as well as being able to control and make sure that the hardware was all the same.
Cool. And so VMware had quite a long development before they really became mainstream, before it really blew up. So when did that happen, and what changed in the technology landscape usage that pushed them over the top?
So that's a great question. So they started in the desktop space, actually, or the workstation space. And the reason for that was developers, right? It became really difficult for a developer to get an environment that looked exactly the same. But with virtualization, there was that virtual hardware that looked the same exactly every single time, and it was abstracted from the hardware below so that there was software in between. That was virtualization. That was the hypervisor. And so they were able to have multiple different virtual machines on their laptop or on their workstation so that they could make changes rapidly. And then if they screwed something up, it was really easy to just delete that one file because the computer was actually just a single file.
And the hypervisor, I mean, this is something that's unique to VMware, right? I mean, IBM didn't do this. Is this something that's really all their own at this point?
Well, on the x86 platform, it was, yes. It's arguable that Linux, Unix, and the mainframe, the way that they operate, were sort of all built off of that premise of multi-tenant architecture. Okay.
And define multi-tenant for me.
So multi-tenant would be taking multiple different resources and being able to break them up and sort of encapsulate them so that, it's kind of like going into a telephone booth. If there are like 3 different telephone booths, you go into one, you've got a telephone. I go into the next one, I've got a telephone. We can make different calls. It's almost like I don't really know that you're in the next booth over because I'm encapsulated. I have my own phone. I have all of that stuff. You have all of that same stuff in your little telephone booth, but I don't really hear what's going on, etc.
Okay. So the example you were giving earlier about having different operating systems, that is an example.
Exactly.
Okay.
And we are super geek fest on this episode. I'm just
Well, sure, yes. It's so important though. And maybe we think it's important because it's just part of what we live and breathe every day, but it's kind of something that I always want to encourage people to say, hey, this is the world we live in. Let's open up our eyes here. And if it only takes, 40 minutes, like we're going through right now, to start to understand it, that's awesome. So I love this geekiness. So thank you for diving into everything.
We're in definite data file mode versus data phobes are probably like ears are bleeding.
Oh no, I hope our data phobes feel comfortable and know that we love them.
So let's continue, right? So now you asked where did this go and how fast did it get there?
Yeah.
So now VMware 2007 they went public, so that's 8 years of company before they go public. The great part about that, or actually the opportunity of that, is when they went public, such a small percentage of data centers were actually virtualizing at that point and collapsing their infrastructure that there was so much upside. And so the interesting part to that is now all of a sudden big players, all the big banks who had 50,000 plus servers in their infrastructure were looking at this and saying, I don't have to build $100 million data center. I can build, maybe just a few of them instead of 20 of them.
And we should probably throw in the little footnote that you were working at VMware in the very early days. True. As one of their lead architects. And do you want to talk about some of those huge projects that you worked on?
I don't.
Okay. Okay. Major projects, we'll just say that. So, but just a good thing to note that you were at VMware. Geez, what time frame was that?
In the early days past when we went IPO. So the golden years.
Yeah, through early and through their IPO. So you saw the crazy hockey stick growth. You saw when basically companies started to realize, wow, I'm missing something by not incorporating this technology, and this is the way of the future.
Exactly. And so now VMware had a little bit more part of this before we get to the cloud. And all of the stuff that we've talked about sort of laid the framework of why the cloud became the relevance that it is today. And so as time went on, people started to say, hey, this is so easy. We went from 2 weeks of being able to buy a server, get it stood up, get power to it, get networking to it, get it put in a rack so that we could use it and then load operating system, Windows or whatever on top of it and get it useful and then patch it and have the security team look at it and bless it and away you go. So they started to say, okay, this is great. We can do this in like 6 minutes now or 30 minutes and get a machine up and running. So part of the problem with that is it started to spin out of control because now you've got templates and it was really easy to just make a server template and then clone it and have 100 new virtual machines up and running. So then came the need for catalogs of machines and being able to take a base image and then apply software on top of that. And so that sort of started to build where the cloud was going and coming from. And so I believe in 2006 timeframe, that's when AWS came about. And so now let's talk about where that came from and why. So if you can imagine a company like Google or a company like Amazon, by the very nature of what they're doing, requires a ton of compute, a ton of memory, a ton of storage.
And are those really the factors that gave rise to the cloud? I mean, with the rapid rate of development and just the amount of data that we're starting to generate?
You betcha, right? It also came to that resource utilization piece. And so if you think about it, a lot of the stuff with Gmail, for instance, I don't know if it's still this way today, but you would always see the number down at the bottom of storage that you could have available, and it was down to like decimals, but you always saw it growing a little bit. Well, what that was is excess storage that when Google stood up more search systems, they were carving off a little tiny piece of every single disk in their whole data center, hundreds of thousands of servers worth, and growing. And they were just carving off little pieces. And then that little piece went into a shared pool of storage that they assigned to Gmail. So they were just kind of using up that excess and hey, wow, they made a product that the public could consume.
And that product, Gmail, was an engineer's 10% project.
Yeah. So somebody built that between
amazing.
Lunch and recess time at Google.
Yeah. Just a little side project.
Yeah. So, moving forward, Amazon, tons and tons of resources needed to basically build out this online e-commerce. Well, challenge with e-commerce, people aren't buying at the same rates all day long. There's obviously seasonality as well. What a great way to make sure all of those expensive resources that you bought are fully utilized. Carve off a piece of that and sell it. So that essentially is taking that to the next level, which is that encapsulation piece and multi-tenancy. That is being able to say, hey, as an organization or a business, I have a resource and I don't use it 100% of the time. And so it could be a plane. It could be the corporate jet. Hey, we only use this 20% of the time. Let's rent the puppy out the other 80% of the time and get some residual funds off it.
So we could liken this to a share economy, right?
We absolutely can. And that's exactly where I was going with this. This is when
different application.
When your Tesla autopilot vehicle when you schedule it and say, hey, I'm going to sleep, and it takes off and heads off into the darkness and goes and picks up people at the airport.
Makes you cake while you sleep.
Exactly.
I love it.
Some mad cheddar stacks just stacking up while
It's
you're
the future I want.
sleeping away. So anyhow, so that really is where that was born from. It was born from excess resources and being able to encapsulate that in such a way that they could then sell the excess. So that's where we're at today. That's actually the one thing that's really making a lot of money at Amazon, coincidentally. So
Cool. And so when a company wants to think about, well, how do I do the cloud? Do I have the right infrastructure? What are some of the things to think about? I mean, it would be probably a little crazy to think that there's a company who hasn't started to dive into this, but it's very common for organizations to take a look at what they have and say, okay, how do I need to improve this given our current needs, how we're growing, what we're getting into? So what are the things to think about?
Well, one of the things that I would say is if you think about why an Amazon or a Google got to the point that they had excess resources and started to, offset those resources by sort of selling them. One of the things that a lot of businesses have also started to do, if they're sufficiently large, there's no reason that JP Morgan or Citigroup or some of these other monster organizations, they have their own, what I call public or private cloud inside of their organization. They have so many departments with all kinds of different needs. They build a private cloud that centralizes everything, makes it really easy to stand up new virtual machines or applications, and then can assign privilege to that into the different groups that need the resources. So that's great. I would argue that because of their economy of scale already, the cloud probably doesn't make a ton of sense other than having some elasticity, right? And so the great part about the cloud is it's born from elasticity and, shrinking the elastic so that if you have to burst up, you're only really paying for the burst. You're not paying for that resource the whole time. So that's essentially what Amazon did.
And you may hear the term, right? Cloud bursting. So these wonderful cloud images that talks about that basically when you need to go from private to public, that ability is there to burst from one cloud, quote unquote, to the other when you need that extra capacity, right?
Exactly. So that would be a hybrid cloud where you have a cloud internal to your organization, and then you have a cloud or clouds out on the public side of things, Amazon or Microsoft Azure or Google or Rackspace or a whole list of them, and being able to move in and out of those as needs arise. So maybe in November before Black Friday, you're going to have a ton of traffic. You need to spin up a bunch of web servers and applications and e-commerce to be able to handle that need and that demand. But then after, January, when all of the returns happen and all your sales are finished and calculated, now you need to scale that back to normal months. So
That makes sense.
Yeah.
So we have public cloud, private cloud, hybrid cloud that connects public and private. How does it make most sense to balance how those are all working together?
So that's a good question. And let's talk about the last 10 years. So the last 10 years or so, maybe a little bit more than that, maybe 12 years, Amazon came on really strong, as well as others, saying, hey, the cloud is here, move everything to the cloud because the cloud is cheaper. And so some of the cost that goes into running a data center for a company is you need tons of staff, you need lots of physical space, you need power, heat, cooling, all of those types of things. So it became really expensive, and many of them weren't built on things like virtualization or things like internal cloud technologies that make it really easy to scale hardware as well as software in parallel. And so these technologies just didn't exist, and it's really, really hard for a lot of these companies to sort of adopt it after the fact. We're getting there in the journey, but we're not quite there yet. And so my advice would be, if I was a new company, or if one question I always love to ask our clients is, if you were to stop everything you were doing tonight and then tomorrow morning just literally take everything that you have to do from a business and do it differently, just start from scratch. We'll take out the super big credit card and buy whatever we need. How would you do it? And when you start talking through things like that, it's usually, oh, well, I would do something like the cloud, or I would, get rid of this or get rid of that, or change this process, or clean up the 70% stuff, the operational stuff that is not letting me innovate. And so insert Amazon, insert a lot of these cloud players. And so they have been beating the drum on, hey, you're going to save a ton operationally. You can get rid of a lot of your staff, and it became a headcount case. It also became a, hey, we could do it cheaper because you don't have to buy the resources and you can get them as you go. And pay as you go, sort of like a lease situation. But here's the reality. And so reality is starting to set in. The cloud is not necessarily cheaper in every case. And I would argue that if you have a smaller organization, the cloud is infinitely more helpful to you, because you probably don't have an IT person. You probably don't have a security person. You probably don't have a networking person and all of these different components. You probably don't have a rack to put a server in. I think of that Wayne's World thing. Like, why would you give me a gun rack? I don't even have a gun. It's so all of these things start to add up, right? And if you don't have sufficient scale, you don't have economies of scale. Therefore, the cloud actually is cheaper. And so we're at the point now where a lot of these companies said, oh, hey, I saw this in a magazine. We definitely should go to the cloud. And a lot of CIOs and CTOs said, hey, we're just going to put everything in the cloud because it's better, cheaper. Look, I don't have to have people, et cetera. But now that's coming home to roost.
And is that because some of these fees aren't completely understood in terms of how you store and retrieve the data?
Exactly. And so transit of data is expensive, and that's a cost that is hard for it to go away. And the other piece to it is competition. So we're back to a mainframe situation where, like it or not, as flexible as a cloud provider will tell you that they can make it for you, it's still not completely flexible because of multi-tenancy, and you have to, sort of have a low common denominator to be able to appease everybody. And so the other piece is there's a lot of statistics out there that actually show that while the cost of hardware and provisioning, software and all of that have drastically dropped, Amazon's prices haven't dropped as far and as fast. So there's starting to be opportunity in having your own, if you're able to build your own cloud internally and you have sufficient size in your organization. Prime example, Dropbox. Dropbox pulled a lot of their stuff back out of the cloud. Netflix pulled a lot of their stuff back out of the cloud because they realized they had so much storage needs that their low watermark, they were paying for that and paying someone else a handsome profit for what they had to store anyway. So what they started to figure out is like, hey, we should really probably go look and see that non-elastic part of our business. Let's go build a data center that scales to that. And then let's use the cloud, the public cloud, to sort of rubber band up or rubber band down as we have ups and downs of the business. So
yeah, it totally makes sense. So, I mean, if we want to bottom line this, so the cloud allows us for easy scale up, scale down. It allows for increased performance, reliability, but it has to be used in the right context for the right size and needs of the organization for it to make sense.
And I would say capabilities too, right? So it is quite a bit easier, and we've got to break the cloud down into a few more pieces. So most of the stuff that we've just talked about is infrastructure as a service. So that is providing virtual hardware that you can then put an operating system on and run an application on. So that's sort of the mainframe days, the client server days, the virtualization days, still operating system centric, but you have to then manage your applications on top of that. So now you get into platform as a service. So platform as a service is saying, hey, we realize that you have to use a web server and that really all you want to do is put web pages out there or some code for your application, but you don't really care about how the web server needs to be configured and all of the underlying infrastructure to make it scale. You don't care about that, or you don't have the capabilities or know-how to deal with that. But you know that you've got to build an application that's going to rapidly scale. So platform as a service is exactly that. The platform is handled by, the cloud, and it takes care of all of that. It takes care of scale. It takes care of fault. It takes care of durability and resiliency and all of those types of things. And so, but you pay for that. So to go back to the hybrid cloud or having resources in-house, the other component is some of this is getting increasingly complex. If you're doing things like machine learning, now you've got GPU and TPU platforms where you've got to build out specialized software potentially to fully utilize the hardware. And so that makes it infinitely more complex, right? And so that's sort of the journey of the cloud. It's not just about operating costs or those hard costs. It's also about capabilities and know-how now, where the cloud may make sense if you're a startup and you don't have all these resources to go and build out a big Linux environment that's super cost effective. Now, when you get to scale and you start scaling, it very well makes sense to bring that in-house. Facebook didn't go and use Google's stuff, right? They built their own and got innovative and got their costs down. Google didn't go and use Microsoft's stuff or whatever. They went and built their own. They didn't buy EMC storage, because that's like a retail storage platform. They went and took hard drives and wired them all together, so to speak, to make the platform that they needed. And they built a lot of that technology in-house, and that innovation happened in-house because they were really sort of hacking that growth and hacking the operational costs out. And with the cloud, it becomes a little more difficult to do that. So I truly believe as companies scale, they're going to start looking at how do we get more operational cost out. And we're going to be back to let's go innovate and do some of this in-house and, build some of our own cool tech.
Yeah, absolutely. And I mean, it's clear that with cloud computing being so accessible and flexible, that's certainly been a huge contributor to innovation, to new companies being able to start because the barrier to entry is low. And that's been really key to the ecosystem that we have now.
I could talk about this for 25 episodes probably. So
I think so.
We probably should think about wrapping it up though.
Cool. Well, thank you. This has been really interesting, and we know more about the cloud now.
Have a great day.
Thanks. Thanks so much for listening. This episode is sponsored by Uprise Partners. Uprise launches startups and evolves established companies. Check it out at www.uprisepartners.com. Please like, subscribe, and share, and we'd love to hear from you. Give us a shout if you have a great idea that you want us to include. Just email us at hello@datamyths.com.